In our last lesson, we talked about parent functions and how all of those have different families. In this lesson, we're going to talk more about the functions that are in each family and how they differ from each parent function based on its transformation equation. So here's the transformation equation for whenever f of x is any kind of parent function, we can transform it based on g of x, and all of these letters mean something different. And so on this graph here, I've got the quadratic parent function, f of x equals x squared, and we're going to transform it with g of x. And so let me slide this down and turn that on. And so first letter I have is a. I see that if I slide a to be bigger than 1, what I'm doing is I'm stretching that blue graph vertically, stretching it vertically so it's getting skinnier. So a is going to be a vertical transformation. And we see that if a is bigger than 1, it's going to be a stretch. We can also make a less than 1. And I see when I do that, now I'm compressing it down so it's getting wider and wider than our black graph. And so if a is less than 1, we're going to say it has a compression. The other thing I have in this equation is this plus or minus symbol. And so right now, all of our a's have been positive. But if we made this a negative, what happens is we reflect over the x-axis, and now that graph is opening down. But I see if my a is still bigger than 1, I'm still getting skinnier. And if a is less than 1, I'm still getting wider. The only thing that happens if a is negative is it reflects over the x-axis. So let's say if a is negative, we reflect over the x-axis. Okay, so that's our a. Let me go ahead and change this back to positive 1 so that we can look at our h value. So h, I see if I start moving it more positive, it's going to the right, and if I start moving it more negative, it's going to the left. And so, but what I want us to recognize here is inside the equation we have a negative h. And so if I change this to be plus, and I start moving this to the right, I see the graph is actually going in the opposite direction of what we would anticipate. So we're going to say that whatever h is doing, we want to do the opposite. So h is going to be our horizontal shift, and it does the opposite of whatever we think it should do. So a positive h is going to, we're going to move left. Okay, so positive h is going to be moving to the left, and a negative h is going to move to the right. Okay, it's going to be backwards than whatever we think it should be. Let's set this back to 0. Our last letter, well, first we have this f, and f is going to describe the function family. Okay, so f isn't really a transformation, it just describes whatever function family we're working with. The last letter that we really have is k, and k is going to describe how far up and down we go. I see that if I move k up, that graph is moving up, and if I move k down, that graph is moving downward. So k stays true to whatever the sign is, it's just the inside part that's going to lie. So k is going to be our vertical shift, and a plus k is going to move up, and a negative k is going to move down. Let's do some practice with this now. So question 1 says function g of x has been transformed from its parent function f of x. Describe the transformations that have been applied when we get this for g of x. And so all we're doing is we're listing all the transformations that we have in this specific equation. And so first thing I have, just going left to right, is this negative. We said if a is negative, it's going to be reflected over the x-axis. Okay, that's the negative. And then we also have this 2 here. Now it's very important for us to separate the 2 from the negative. Okay, we talked about if a is less than 1, it's a compression. So you would think -2 is a compression, but we've already used the negative for our transformation. So now we're looking just at the number 2. Since 2 is bigger than 1, it's still going to be a stretch. It's going to be a vertical stretch. It's just going to be opening downward as well. Moving inside the parentheses, remember f isn't really a transformation. It just tells us what kind of function it is. But here it doesn't really matter what kind of function it is. We're just finding the transformations. This +3 is going to tell us how far left or right to move. But we remember that we're always doing the opposite of whatever is inside the parentheses. So a +3 is actually going to tell us to move left 3 spaces. And then finally on the outside, this is our k. And since k is negative, we're going to move down 1. Okay? Come here, Raider. You want to do some transformations? This is my dog. He wants to be with us. Okay. Question 2. Now that we're given f of x is x squared, so this is our quadratic parent function. G of x is this. So what kind of function is g, and how does it differ from the parent function? Well, this is pretty much the same question. So first, we're told what kind of function f of x is. It's a quadratic. So g of x is also going to be a quadratic parent function. And so let's see how it's different from just the parent function. So first, we have this 1/3. 1/3 is less than 1. So it's going to be a vertical compression. Okay. It's going to stay up since it's positive. So we're not reflecting it over the x-axis. Just the 1/3 is less than 1. So it's a vertical compression. Now we have this -1 inside my parentheses. Since it's inside, we're going to do the opposite of whatever it tells us to do. So the negative is going to tell us to move right 1 space. And then finally, the +2 on the outside, that's my k. It stays true to whatever the sign is. So we're going to say to move up 2. Last question, number 3. We're given that the parent function is the absolute value parent function. This time we're going to write an equation for g of x that's been vertically stretched, shifted down, and right 2 units. So let's do that. So g of x, in order for it to be vertically stretched, my a has to be bigger than 1. We can pick any number that we want. So maybe we could just say 3 since that's bigger than 1. Instead of writing the f this time, I want to write exactly what my function is, which in this case is the absolute value. So instead of writing f in the parentheses, I'm going to write my absolute value bars. Then I'm going to have my x, and I know inside is going to tell me to move left or right. So since we want to move right 2 units, I need to make this a -2 since it's the opposite when we're inside. And then finally, we want to move down 3 units. So we're going to do -3 to go down. And that would be the equation that has those transformations with it. Let's look at one more example. This time we're trying to match each graph to whatever equation that it would be. So for this first one, I see that my dotted graph is my quadratic parent function. This black graph, the solid black graph, is shifted upwards. So I think which letter shifts up? Well, it's the letter on the outside being added. So this b of x would go with this equation. So I'll write b of x. And now I've used that one. This one, my solid graph, is reflected over the x-axis from my dotted graph. So the reflection is the negative on the outside, which is this h of x. So h of x would go with this graph, and I've used that one. Now my black graph is skinnier than my dotted graph for this one right here. That's a vertical stretch, and we say that that's the number being multiplied out front, which in this case would be g of x. That's my 3. And then last, this graph here is moved to the left of my dotted graph. So I have to add 2 inside the parentheses. So this is going to be a of x. Now, I hope you had as much fun as I have working with function transformations. Good luck in your practice, and I'll see you in the next video.